Say you're the mayor of a city or the president of a small country. The situation of the COVID epidemic is relatively stable in your region, and of course, you would like to keep it that way. However, the situation around you is different. There are neighboring regions which face higher number of cases. And this raises the questions, should I stop having contacts with them? Should I not let people from these zones get in? The objective of my project is to provide a statistical framework to answer these questions. To do so, we need to take into account two factors. Firstly, the number of contacts and exchanges you have with that region. The higher the contacts, the more possibilities for new infections. The second factor is the proportion of infectious individuals in that region. However, there is a problem. This number is unknown, and we need to estimate it. The number of positive tests alone is unreliable due to the fact that testing across different zones is extremely heterogeneous and due to the large proportion of asymptomatic cases. The main idea is then to only really trust the deaths data, deemed much more reliable. That way, we can infer the number of infectious individuals and provide forecasts, which can then be used for strategical planning to fight the epidemic. In the first part of my project, I focused on the infections component of this model. In particular, we took inspirations from models developed for European countries and US states and adjusted these to study populations at a smaller scale. We considered counties in New York, New Jersey, and Connecticut, which were some of the states with highest COVID mortality in the US. An interesting and maybe counterintuitive phenomenon is that a few counties account for most deaths in each state and drive the state-level mortality average. Running our models reproduced this heterogeneity. The estimates of various parameters of interest, like R0, varied substantially across regions. However, predicting what is going to happen in the future is not an easy task, especially at a small scale. We found that it is much easier to predict deaths at a state level rather than at a county level. In the future, we want to introduce the mobility component, for example, allowing infectious individuals to travel across different regions. This may help better explain new waves of infections in smaller counties. To conclude, our work tries to answer the question, in which regions are infections growing more dangerously? This is not easy to answer, but if we're able to identify the most dangerous regions, we may avoid statewide lockdowns and apply more specific interventions. More work needs to be done, and so in case you're interested to know more, make use of our results, or help out, you can make use of our code. We modified the R package Epidemia, which you can find on GitHub, with my personal changes in the branches Andrea and continued seeds. I would also be very happy to answer additional questions sent to my email. Thank you very much for listening.